Hi, I'm Michael Hart, a Senior Software Development Engineer at AWS. I'm here to tell you about how to extend protocol support for equipment data ingestion. This video will show you how to configure and use data sources from our partners with your AWS IoT SiteWise Edge gateway. Let's take a look at an example. Let's imagine you have a wind farm with turbines. The turbines feed data through an AWS IoT SiteWise Edge gateway and into AWS IoT SiteWise. Now you want to add data from the power transformer into SiteWise, but it doesn't use a protocol supported by SiteWise Edge. How can you input that data? This is where partner data sources come in. You can deploy an EasyEdge data source from AWS partner Domatica to your gateway, which does support Siemens S7 protocol. This data source can talk to the transformer and feed its data to SiteWise Edge, and from there into SiteWise. Now, thanks to our partner, all of your industrial data is available in SiteWise. Domatica is our first partner to provide SiteWise Edge data sources. We can easily set up a partner's data source, such as EasyEdge, within the AWS console. Simply add the data source, configure it through the partner site, and it will deploy into an existing gateway. Deploying data sources from partners gives access to their protocols and features, including 10 new protocols with EasyEdge at launch. The data sources integrate with SiteWise Edge, so data will arrive in SiteWise seamlessly. EasyEdge allows users to select from an existing library of devices or build their own devices and templatize and reuse them. Here we can see the protocols available through EasyEdge by Domatica. Using their data source allows any data arriving in these protocols to be integrated into SiteWise. Let's see how to set it up. Here we have our SiteWise Edge gateway, which has been deployed to an EC2 instance. We can see in the data sources that the OPC UA collector and simulator have already been deployed. Please see the video link in the description for a demonstration of how to set this up. Now we want to connect it to our transformer, which is transmitting using Siemens S7 as a protocol. To do that, we'll add a data source. Select EasyEdge, give it a descriptive name, and check the Authorize box. There are information boxes saying that an EasyEdge account will be required to complete the configuration, and that Docker must be installed on the gateway. I've already installed Docker on the gateway, so I'm going to sign into EasyEdge. And then save the data source. As we save the data source, it opens a new tab in EasyEdge that will allow us to complete our configuration. The default values are fine, so I'm going to click Next and Finish. Now, in our gateway, our data source has been created. And in EasyEdge, we can list our edge nodes and see that our node is onboarding. Let's wait for this to complete. Our edge node is online, so let's proceed by adding a device. We can select Siemens S7 client, and we have a few options for setting up our connector here. In a real-world scenario, you are likely to have a file describing the data available for use with this Create with JIT connector option. If you select this option, it will automatically fill out all of the fields that I am about to set manually. However, with my data source, I don't have that file, so I'm going to create from scratch. I'm going to set it as voltage. These parameters are correct. And I'll set it as an unsigned short integer. I'll set the name. and I'll set the address to localhost, as well as a PDU size. This setup will be custom to your component if you're not able to import a file for your parameters. Click Finish, and we're ready to deploy. We can deploy our solution when ready, and we'll wait for this to complete. Now it's finished deploying, we can take a look at the voltage measurements. With voltage measurements coming in, we want to connect this to our SiteWise asset. In SiteWise, we want to make sure a model exists for the transformer. We have this simulated transformer asset model. It has these measurements available, and we're going to connect the voltage to our voltage measurements. We'll make sure an asset exists for the model. Here is our asset, and we can see there are currently no measurements. Now we can open the data streams and see that there's a new data stream available, apart from the ones created by the OPC UA collector and the simulator. This S7 source is providing voltage. Let's tick this and manage it. We can choose the measurement. Then under the assets, we can select the transformer asset voltage measurement. Select Choose and Update. This associates the unstructured voltage data with our structured data in SiteWise. Now, if we look at our transformer asset, we can see that the values are starting to arrive. So we've seen the S7 set up through EasyEdge, but we can do more. Let's set up a Modbus connector to read the current from the transformer and a workflow to calculate the power. The first step is to create a new device to read our Modbus data. We select Add Device, click the Modbus client, and again we'll create from scratch. Our name will be current, and these parameters are correct, except that it's a holding register, not an input register. We'll give it a name and click Next. Our communication type is TCP, and our address is localhost. We're also using a non-standard port, which is 5020. We click Finish, and then we need to deploy again. Now that our deployment is complete, we can select our Modbus source device, and we can see our current values coming through for our Modbus source. To keep better track of how our data will be stored in the workflow, we want to create a device in the device library. To do that, we click Library, select our Northbound Data Models tab, and then add a data model. We'll create from scratch. We'll have voltage, current, power, and a status message, which will be a string type where the others are integers. Next, we'll give it a name. And click Next. Click Next and Finish. Now we want to calculate the power. To do that, we can create a workflow. We'll select the Workflows tab and add a new one. This is a drag and drop, no-code programming interface for calculating measurements based on existing data. We're going to use this workflow to calculate a power value by multiplying together the voltage and current, and then compare that power to a threshold to see if it's under a minimum power. To do that, we'll first expand the window and select our data sources. The first thing that we're going to do with these input values is to multiply them together. To do this, we'll go into the code block section and select the multiply block. I'm going to name this power calc. Then we can click on the current arrow and connect it to the multiplicand, and the voltage arrow and connect to the multiplier. Now our output will be the product. At this stage, we can feed it into our output. We can select our transformer model, and connect the current, the voltage, and the power. However, we want to get a bit more advanced with this workflow. So the next thing we're going to do is to create two error messages. One will contain the error message no errors, and the other will contain an error message that the power is too low. Now that we've calculated the power, we want to compare it to a minimum threshold. To do that, we'll use an if block. I'll name this power is low, and my condition will be if value 1 is less than or equal to, and then I'll select this configure button and enter the value 420,000. If our transformer power is producing less than 420 kilowatts, we want to create a warning message. Now we can connect our product into value 1. The result of this if block is that a 1 will be in the false arrow if the power is not low, and a 1 in the true block if the power is low. Now we want to format our error message. We'll have two error messages. One will take an argument, which is when our power is low and we want to output our measured power. And one is when our power is not low and will simply be a fixed string that we don't need a printf block for. So we'll bring one sprintf block in, we'll set its name to power low message, and then we'll configure it. Our format will be power is low, measured %d, as in C string formatting. We could pass in a second argument for the threshold, but just to simplify it and keep fewer lines on screen, I'm going to type it. Minimum 420,000. We'll click save, and now we want our argument to be the power. To make the printf block trigger, we need to give it a trigger, meaning we only tell it to format the message when the trigger goes to 1. For that, we'll use the power is low true. When power is low goes to true, then our trigger will be triggered and our string will be formatted. Now we want to select which error message will be sent to our status. It will either be power low if the power is low, or it will be no errors if the power is not low. For this, we'll use the switch block. We'll use the upper switch block and call it power low switch. This is enabled when the power is low, and the input is the result of our string format. Our output is the status field of the transformer. Our other switch block will be power normal switch. It will be active when power is not low, and we will set our input inside the block. For both blocks, the data type must be set to string. We'll configure it, and our input will be no errors. We'll save and connect it to the status. Let's check back through our diagram and make sure we understand what's going on. First, we have two inputs. For both inputs, we are connecting them directly to the output for our current and voltage, and we are multiplying them to get the power and connecting that to the output. We're also taking our power value and comparing it to a minimum threshold. If it is below the threshold, we format an error message and send it to the output. If the power is not low, we output an error message of no errors. This is our output. With that, we'll save and deploy. We've deployed successfully. Now let's turn on real time and see our measurements going through the system. We can see our current value coming in and our voltage coming in. We can see that our product is randomly moving around because the simulator is just using random values. We can see here our string format block formatting our error string. And we can see our output contains the current, the voltage, the power, and the status message, which is usually no errors, but occasionally flashes up with an error message. This workflow demonstrated some of the edge capabilities of EasyEdge. If you're interested in more advanced workflows, please follow the link to Domatica's video in the description. Now that we have this data coming from EasyEdge, we want to connect it to our SiteWise asset. Again, we'll open SiteWise and go to Data Streams. Now we have new data streams from our transformer model. So we're going to manage our old voltage data stream and disconnect it. In our data streams, we can see that our transformer model has voltage, power, and current, and on the next page of streams, status. We can select each of the data streams and manage. For each of the data streams, we'll choose a measurement and select our transformer asset and attach the relevant measurement. Then click Update. Then if we take a look at our asset, Measurements tab, we can see that our current values and voltage values are coming through, as well as our calculated power values and our formatted error message. So there we have it. We've seen how to add an EasyEdge data source from Domatica to our SiteWise Edge gateway and seen data flowing into SiteWise from our gateway. We've also seen how to set up a workflow to calculate data from our data sources. I hope you now have the information you need to try the advanced partner data source features for yourself.